Our today's podcast guest is someone who converted his college project into a real life AI company. This podcast is very special for those who are in their college or is someone who want to start their own venture or anyone who is on the early stage of the entrepreneurship journey. Listen to this podcast till the end, and this is a free masterclass for all of you. I'm sure you'll have a lot of learning from it. Saying that, I welcome my podcast guest, Andrea, to the podcast. Happy listening. Hi, Andrea. Thank you so much for joining this podcast. I think this was going to be very exciting podcast, and especially for those who are at very early stage of their entrepreneurship journey, or those students who are having their study, or they are undergraduated, or doing their study and looking to start their own ventures. So thank you so much for taking out time and joining this podcast.
Well, thank you so much for the invite. I'm very happy to have this conversation today.
Awesome. I already know you, and I worked very closely with you on one of our projects. But just for the context of our audience, if you can, please let us know about you and your journey. How was it, and what are you doing currently? What's something exciting that you are up to right now?
Definitely. I am Andrea. I'm the one of the co-founders of Dimitracopoulos, which is an AI startup in the UK that's focusing on accelerating the development of life sciences innovations, with a particular focus on drug discovery right now. But I wasn't an entrepreneur for a long time of my career. In fact, I actually started as an academic, I will say. So I have an interdisciplinary background. I did biomedical engineering at university in Italy before moving to the UK for a PhD at the interface between physics and biology. That then was followed up by a postdoc in neuroscience, again at the interface of some computational methods, actual biological experiments. So I was wearing a lab coat in the lab doing experiments, and many other little things like some biochemistry, some microfabrication, some more engineering. So it was very, very interdisciplinary, and I feel like that's what has been kind of the theme of my career in academia, and then actually also beyond now with Dimira. So in some ways, I would say probably for about 12 to 15 years, I was a pure academic. I'd actually never really worked in private companies, and I saw myself for a long part of my career as potentially becoming a group leader, starting my own lab and do research, again at the interface of physics and biology. And I think it was a particular project I worked during my postdoc at the University of Cambridge, here where we are talking today. It's so great to see you actually in the UK for this short period. I know you're going to be back to India very soon.
Thank you so much.
And that was when actually I started working very closely together with another researcher who then became my co-founder at Dimira. And the project was actually very simple. It was a very simple idea. We were working in neuroscience, looking a lot at images that were coming from a microscope. So we would put biological cells in culture, and we would look at how neurons, so brain cells, were developing. And we'll take photos of them and look at some specific parts inside these cells that will help us understand the developmental process. So how do neurons grow, make connections, and then become, what they useful for, thinking and processing information in the brain. And Max Jacobs, who is my co-founder at Dimira, he had to do a lot of manual analysis. So he had to process a lot of images at the computer after acquiring them at the microscope. And this was a very tedious process. So now we're talking about 2018, so like 5 years ago from now. And I remember he was very frustrated at the idea of having to spend so many hours after being at the microscope and in the lab also doing this analysis. And that was a period where artificial intelligence was really starting to demonstrate some clear benefits in accelerating especially certain image analysis workflows. So there were a couple of things that Max had started already to work on. So he was working on the idea of instead of writing up a software program where he had to say very explicitly to the program what to do with these images to try and replicate what he was doing manually, and then taking a tenth of a time, maybe a hundredth of a time. He was trying to explore these artificial intelligence tools that would basically just learn from examples. Mm-hmm. So instead of saying explicitly what you had to do, what you could provide was an input, which was the image from a microscope, and the output, the image after Max spent maybe 15 minutes tracing certain shapes on this image that then would be very useful to understand biological processes. So he assembled together a few hundred examples of what he wanted the output to be, and used and started building a software where it would learn to associate input and outputs automatically, so that seeing enough examples, given an input that was never seen before, it would be able to replicate the analysis that he was doing manually. And when I moved from my PhD, which was actually working on cancer cell biology, towards neuroscience, I remember being very, very fascinated by all the advancements, both in the neuroscience research in biological systems, but also in artificial systems. So this was like towards 2015, when again there was like this kind of like picking up. So I remember like talking about this project with Max very closely, and started to look at how he was developing some of his software. And then there was a clear moment in which Max was not only very interested in having this software for himself, but we started talking a lot about how to make it available to others. And actually not only available, because even then people were publishing the software in terms of like just the program, like the code used to run the software on something like GitHub, which is a web platform where programmers can share code, make it open source and available. But one of the main problems was that there was a lot of software that was available, but once downloaded, people could not run it. People could not replicate what was done. And so we started talking a lot about accessibility. So how can we make not only the software available, but also accessible and very easy to use for people that maybe are not programmers, maybe are pure biologists and have the same problem that we were having, but can't program like us because we had this engineering and physics background at the interface of the two. And I think that was kind of like the kind of spark that started the idea of Dimira, the idea of making some of this software very, very accessible. And even in that particular project that led to a scientific publication, not only we put the software available online for people to download, but we made a web app so that people didn't have to download anything. They could just drag and drop an image, click a button, and they will get the answer back, which was like the automation part. And basically that's how Dimira started. The idea was like, okay, can we accelerate a lot of this analysis that now is taking like potentially weeks, potentially months, and reduce it to hours or days? We were really motivated by it. And we spent quite a lot of initial time trying to understand how could we make it work really, really well for images, because that was what we used to work a lot with. And then at some point, and then I can stop in a second, let you ask me a few more questions. But at some point we realized the images were kind of just the start, because there were a lot of biological experiments that would benefit from acceleration that actually you need a lot of equipment to run. If you want to analyze an image, you need an expert person, but more or less, then you need about 5 to 10 minutes, maybe half an hour, and that person knows the answer. For many other experiments, you need a whole lab. You need a lot of very expensive reagents and a lot of time to run one experiment. So if we could start predicting the outcome of experiments instead of images, that would have been a lot more value we could add to labs, both in academia and industry. But I'm going to stop for now, because otherwise I can just keep talking for hours about it.
No, it's really interesting. Through this conversation only, I got a lot of questions. And I'm sure those audience who listening to this podcast also might have a lot of questions. So first question is that you already had like a multidisciplinary background, like medical, biomedical, then neuroscience, and learning or building a tool, doing programming, and that too in AI or machine learning is even sometimes harder for software engineers who are doing the uh, web development technically, and when they want to move to the AI, it's even difficult for them. Then how did you did that, do that?
That's a great question, of course. So I will say that some of the ways in which we were already doing programming in the lab is something I would call more like prototyping. Mm-hmm. So I think as a researcher in academia, you tend to pick up a lot of skills that can solve a specific problem, but then they don't scale very well. Mm-hmm. So I will say that worked for us. So in the sense that, especially for AI, there were a few particular software packages that were simplifying a lot of the groundwork. Mm-hmm. So at that time, there was a shift from TensorFlow, which is a Google library that enables machine learning, towards PyTorch, which is was born from Facebook, now Meta, and those things, what they do, they just allow you to
use the existing packages.
Yes, the idea would be that you do not have to write a lot of the groundwork, but there's still a lot you need to understand in terms of what are the steps involved, and there are many steps involved, and and actually the devil normally is in the detail. So now it's very easy to build something, but it's very hard to really be conscious of all the different steps that contributes to some software that works better compared to something that works less good. So I will say we basically were kind of hackers initially. So we kind of hacked a first version together. And I remember that working together with Max, but certain things was really hard actually to work together because we were not trained programmers. Mm. So there was a lot we had to pick up ourselves. And when we had to exchange code, we didn't know the best practices back then. And it was a bit complicated to really coordinate it very well, which actually kind of leads naturally in this conversation of the role of Ryan, who is the third co-founder of Dimira, who was also involved in similar research in the same lab, but at the same time he had taken more of a programming path. Mm-hmm. And started to work with a lot of startups in the Cambridge and London ecosystems and started to build systems that could scale very well, doing a lot of the software engineering work that Max and I were not really familiar with initially. And then what we did then, we realized the potential, the potential of what we were building, but realized that just building a prototype that works well for one application is not enough if you want to build a proper company. And so we brought Ryan in because we knew with that extra set of skills, we would be able to then make everything scalable. Yeah. And that actually was the perfect missing piece for the company.
And as they say that, if you know that your strength lies in something, you should focus on that. And if you need, help in other sector, you should bring in that particular person so that you can focus on your strengths and you can scale.
I mean, that's another great point. And even after that, there's many. So just to give some more context, at this stage, we are still all three of us kind of still doing research in the lab. Max and Ryan are wrapping up their PhD project. I'm still working on my postdoc project. So there's a lot going on in terms of working on multiple things at the same time. But something that fast forwarding a couple of years, when we're all full-time now on Dimira, even that as co-founders, you're kind of doing a bit of everything over time. But over time, and I think it's kind of a natural situation with startups, but I think what works very well with us is that we have a certain level of fluidity in terms of what we starting to work on in such a way that we ended up focusing more and more on what we were contributing the most. And that's why, and just to give you a more practical example, that's why eventually Max now sits leading the role of fundraising and sales and customer and client I would say client interactions and investors interactions, where Ryan is really sitting at the leading seat of the technology development, and I sit now at the product development, which is something that I didn't even know exactly what it meant just 5 years ago. But that really meant that, as you say, because it was a more natural fit for me, and I was really, really interested in thinking about how the technology interfaces with users directly, that's exactly what product is.
Exactly.
We spent a lot of time initially working on the technology, but realized just took more and more, developed more and more awareness of how all these tools that are very powerful mean nothing if a user can't use them very, very easily. And so that we just pushed a lot in that direction in the last year.
Awesome. And if I can ask you, how much time it took for you and Max to create that initial prototype, like learning AI, doing everything on your own, and launching that first prototype? How much time do you think it took you?
Okay, that's a great question. And now, after 5 years, it just feels a bit strange to go back in time in my head. So again, it was linked to a research project. So it was a very, very specific problem. So we are now not talking about the idea. So we can talk about everything, of course. But if we are talking about the idea of solving one particular problem, I think we are talking, but very well, we are talking about a few months. And I will say it would be very nice to ask Max, because at that time he was leading almost all of the software development. I think I started to come in the project where we were thinking about how to make things more accessible with a web app, and also the open source, free to download software. So a lot of the first part of this project was purely Max driving it. That part, I think it was a matter of months. But it would be really interesting to ask Max as well in the future if you have a chance, because a lot of that was also linked to the quality of the data. Because in every machine learning or AI application, the software used to learn from the data is only half of the story. The other half is like, okay, what is the data like? How clean is it? Who annotated it? And I remember at some point, because I think I have a lot of attention to detail, remembering looking at this data and thinking, oh, we can improve it even better. And so I spent a lot of time making the data set as clean as possible, and that actually had a massive impact on the performance as well. So that's one part, and I'm going to pause in a second to see whether that's what you want to know as well. Then after that stage, the first product we worked on was this idea of a software platform that, given any image problem, could then make a solution for that particular problem. So now we are going from neurons at the microscope, where we're trying to find a particular part of these neurons automatically, to maybe something has to do with other biological systems, maybe a tissue of the skin or a tissue of the liver, nothing to do with the brain anymore, but what are the implications of trying to make something general? And that took, I would say, probably another half a year to try and make it scalable, try to make it available on the web in a way that could work very, very seamlessly. And that was a prototype we took a while to work on. And when it was ready, we actually realized, oh, maybe we shouldn't work on images. And when we put it on the side and started pushing towards molecular data, which is something really useful for health, and we can talk about it if you're interested, and but presents a lot of other challenges as well.
Nice. But that same fundamental worked for this molecular data as well.
Exactly.
If you need to explain your product deeper, basically, to a non-technical person in a layman language, how would you do it? Yes. What it exactly do?
Yes, definitely. So the idea is that especially for most research and development, so most R&D in the life sciences application relies on experiments researchers do in the lab.
Correct.
And especially for developing new medicines, one of the main ways we develop new medicines is through something called drug discovery.
Correct.
So the idea is that we identify something that's wrong when a person has a disease. So for example, it could be a part of a body that works not as expected. Sometimes this could be linked to a gene or a protein, which is basically like a very small part of a body that now doesn't work as you expect. So if you identify that, so then what you can do, you can try and use a library of molecules, which is kind of like very, very small chemicals that you can try and make interact with this protein that now, with this part of a cell that now doesn't work so well. And sometimes you can either restore the function that's lost, or if a function is actually doing harm to the body, you can try and stop it stop this part of the body to do harm to itself. And so this is what normally would be called like a chemical screen. So you will have tens of thousands, hundreds of thousands, maybe millions of potential candidates that could work as a medicine, but researchers don't know yet. So they start from somewhere, they have years of experience, so they know a little bit where to start, there's a lot of published literature, and they start making an initial selection of what to test to treat a new disease. So now, they might do 50, 100, or maybe even 1,000 experiments in the lab, and then the data comes back, and they look at the data. You can imagine a spreadsheet with a long list of, with many, many rows, which are all the experiments you can do, but only, there would be like, let's say, 2 columns. One which is the experiments you want to do, and the second column is the measurements you collecting from the lab. And you might have, I don't know, 10,000 experiments you would like to do, but you only collected 100 from the lab in the second column. So the idea is that ideally, what you would like to do is to fill all the missing values of this spreadsheet in a way that is really accurate. But how to do that automatically in a way that is very general? Again, like some people might make it work very, very well for a certain disease, but how can it work on any disease that any person, any researcher might be interested in is a very complex problem. So in some ways then, again, trying to explain it in the simplest terms possible, what we're trying to do is, based on very small amounts of information that comes back from the lab, how do we help users to select the next experiments to do? And ideally would be, well, through AI, we can learn very well and effectively from the experiments they have done, and then try and predict the results or the outcome of experiments they've not done yet. And we're putting this together into a web application. So there will be a web page where people can just log in, upload their data very simply as a spreadsheet, click a button, and says, now predict all the missing values of my data, and then we show the results, and we explain what we did, and we explain why we think this is accurate, and then can take it from there.
Awesome. Very interesting. So in the entrepreneurship journey, I'll go to the more now. We talked a lot of details about the technical and how we built the projects. Now I'll go to the other segment on how, commercialize it. Now, as an entrepreneur, whenever anyone wants to launch the product, the few questions that they get generally, or they have advised or thought about, is to check the market size. What is the customer base that you have? What is the commercial model that you'll have? And how you will raise the money? What is your valuation that you think of your product, and by when you think it will be profitable, so on and so forth. So, what was your experience on this commercial part? I'm assuming, and correct me if I'm wrong, because you and Max were from the same domain, so you knew that market already. That this is an issue, this is a definite issue, and this product will solve this issue by making the overall process efficient, and it will save X amount of money to researchers. So you knew that, I'm assuming, and that's why you started with that. But
yeah, I mean, that's a fantastic question, and I'm sure we could spend hours or days talking about it. But in terms of your assumption, I will say, I cannot talk for Max, obviously, but in my perspective, I knew nothing about marketing. I knew, in terms of market size and understanding markets, I knew almost nothing about this industry, like the pharma and biotech. So it was actually, it was a learning curve. Because I think even if you're in that domain, you sometimes, I don't know, I can imagine even people that maybe work in pharma, but they're not working in the managerial roles or the leadership roles, or maybe like in actually the business development roles. People that are just in the lab making the actual new drugs, they might not know about market sizing necessarily.
They might not think about it.
They might not think about it. And when we were thinking about our research, it's a kind of like intuitive that anything that brings benefits to life sciences, it's a big market. Now, in retrospective, if you're working on solving any kind of health-related problems, it's a big market. Everybody's interested. There's 8 billion of people in the world. Everybody's interested in making their life better, longer, and healthier, and improve the quality of life. But at that time, for me at least, it took a little bit of time to learn exactly the language of the business-related activities we were starting to do, and it was incredibly helpful to be in the kind of ecosystem we're in. So Cambridge is a small city. I mean, by Indian standards, it's probably tiny or like a village, but there's a very high density of innovation, both in academia, in business, the startup ecosystem as well. So the first steps that led us, I mean, especially I can talk for myself, that led me to understand more about all these business-related concerns was Max applying for something called an accelerate program. So it would be like kind of an accelerator, but it was called the Cambridge Judge Business School Accelerate program. And they were taking in people that had an idea, they wanted to explore the commercialization, and they just wanted to learn a lot. So we went through about maybe 8 to 12 weeks of this program where mentors and lectures would explain to us, concepts like TAM, SAM, and so on, like all these acronyms that make sense if you know about sizing the markets and all of that. Yes.
Sorry, just to interrupt you, and just for the understanding of our audience, Accelerator is an program that many organization runs to provide that ecosystem with mentorship, maybe technical abilities, and that network that you need to commercialize your product.
Exactly. Thanks for specifying that. That's exactly clear. And at that point, things like market size, business models, intellectual property, all of these things became a lot clearer. So now you actually are the problem is once you know things, it's kind of very hard to remember what it felt like not to know things. So to answer your question, we very quickly realized that the drug discovery market is very big. And it's something that in retrospective, it's also said in the news, you might have come across already the idea that new medicines take an awful lot of time to make.
Correct.
There's lots of diseases for which we don't have a cure. We know some parts of the body that don't work as expected that we could work on, but it takes on average between 10-15 years to make a new treatment, and it's in the range of $1 to $2 billion to actually make it. So we realized very quickly that once you learn the basics, you realize, very quickly, if you can speed that up even by 10%, you're talking about saving hundreds of millions of dollars, which then could have impact on the pricing of these medicines for the end users and on a lot of other related matters such as like healthcare providers and everything. So it's something that the more we learned, I mean, I can talk about personally, the more I learned about, the more I realized there was a lot of value we could add. And that's something also that I don't know. Before I started working in our startup, I used to think about the idea that people that work in industry are concerned about money. Like market size, it's all about millions of dollars, billions of dollars. It's all about this money. But actually, it's not really about the money. What it's about is about value. If you can build something that's valuable to people, then one way to then capture some value back is through money. But when if you're talking about stimulating conversation about students and people that are really early on, as long as you get some value back, which is like increasing your network, solving problems for people that then can solve your problems, you're just adding value to the whole system, which is great. And money is part of it, but it's not really about the money by itself, if that makes sense.
Yeah, so if you figure out the problem and you're actually providing that solution, that money can be a byproduct of it.
Exactly. Okay. But it might be that you get other things. Maybe you work on that, and then in some other ways your problems get solved, and then you're getting value the other way. And it's a bit abstract, but it does work this way.
Agreed. Now, as a co-founder, you are still in the process of raising money and everything. So, what do you think, how one should go about it as per your experience?
Another great question. So our experience, I will say, was I don't want to say it was easy because nothing is easy, but I will say we were very privileged to be in a network of people that supported us from very early on. So some of this support very early came, of course, from the networks we were building through the accelerator program and through the community at Cambridge and in London, in the UK. But actually I had some friends that didn't stay in academia after being studying biomedical engineering as I did, and they went on, had like industry jobs, and they were really, really happy to use some of their savings and put them into an emerging, like a startup like ours, because when we started talking about these problems, they really believed in them, but of course they couldn't work on them themselves because they now have like jobs with bigger companies. So that was really helpful, and in that context, some of the tax relief schemes that the UK has to support investors to put money in very early and high-risk small companies was really useful, because then if anything went wrong, it meant that they wouldn't lose 100% of the money they supported us with, but we would lose only a smaller part of that. So I'm sure that had a big impact, and has a big impact in supporting smaller companies. And I think the UK recently took even more steps in making this a little bit easier. So they even increased a little bit the amount of money small startups can have that has these tax reliefs for investors. And I think that's great. And I'm sure there's many different versions of this in other countries outside of the UK as well. I think Italy, where I'm from, has a similar scheme. And I think that's great. And being aware of these. So these are some of the things that if you're aware of very early on, then you can make better decisions than we did, for example, because we incorporated in 2019, but actually raised some money through these schemes almost after the deadline, because there might be some deadlines that allow you to use these schemes, and we didn't go past it, but we were very lucky to be in a network that reminded us there was this deadline. So again, talking to people, understanding what other people have done in similar fields, maybe not solving exactly the same problem you're trying to solve, but understanding how they went about and what made it work is something you can learn on without having to make all the mistakes yourself. So one general takeaway for me is always you are going to make mistakes, you're going to learn from them, but try to make valuable mistakes. Don't make mistakes you can avoid very easily with a chat or like something like a web search or something like that.
Yeah. And I think this is what I think Fiona also mentioned in our last podcast, that you just need to go and talk to people. You just ask for help, and many of them are ready to, offer you the help, which solves a lot of problem.
Yes.
Great. I was about to ask the next question, which was regarding why there are a lot of startups I'm seeing in UK, which you already answered. The overall ecosystem that we have here in UK, and also the government policies which provides the grants, and even university spin out companies, they get a lot of grants and supports. And for the businesses, it provides those tax benefits. It is also very encouraging for those investors to invest in the early stage companies. So that's great. The last question, I won't take much of your time, but last thing that I want to know from you, as investor will always look for a good product, which can help them provide better ROI. But as a co-founder, you must be also looking certain qualities of investor. Of course, you do not onboard all the investors. As a co-founder, what are your checklists that investors should be like this?
Another fantastic question. Some things I think are easier to. So parts of his answer can be expressed more in a rational way. So, for example, on top of the money that you ask an investor, what else comes with a relationship?
Correct.
It's kind of a relationship, not like a romantic relationship, of course, but it is a relationship that will last over, ideally, many, many years.
Yeah.
And investors are people that will take, in exchange for money or other types of support, they will get a part of your company. And once they have it, it's not so easy to buy it back or to trade it back. So being very mindful about who is added to the cap table of a company, so who is owning parts of a company, is very critical. And I heard stories, luckily we were really privileged at the Mirror, so we didn't have any stories that kept us awake at night, but I heard from other founders in the area that very early on they didn't realize the implications of taking money from certain firms or from certain funds, and then they had to go through some kind of different hurdles either to buy that back or to just change trajectory.
Because they also have their own opinion and voice that you need to hear.
Yeah, so that's a great point. Yes, absolutely. So there could be that. So there could be that the relationship becomes a conflictual one because you have certain ideas for the company, and maybe these ideas, for whatever reason, were not communicated extremely well at the beginning, or they change mid-course, and so now your intentions are not as aligned as they used to be. It could be actually even more pragmatic, that maybe some of the terms of the funding round, where the shares were, the parts of the companies became owned by the investors, maybe there are certain terms that are really specific to this investor, and then future investors have a disadvantage compared to the previous one. There's a lot of details in this, and then that's why talking to people who have been through this before, seeing template agreements that are really fair, and making sure that you don't sign anything before, like double checking 20 times, it's really, really important. So that, in that sense, but this is kind of like the basics. So one would want, of course, to be aware exactly what's being signed and what the terms are. But beyond that, so what can investors provide? And again, it's potential networks, potential support in many different ways, and we are extremely privileged in the sense that we had an array of angel investors that invested money in Dimitra until now. So we didn't go through any venture capital firms yet. But one of the things we thought very, very carefully about when we thought internally about taking money from a VC firm, which normally is a lot more money than what we took in at Dimitra right now, is, so the question is, why are we asking for money? So now we are a completely software company. In the life sciences, you can have multiple types of companies. Some companies will require lab work. And lab work is extremely expensive. Reagents are expensive. You need a lot of physical space. But software development, because it's been, the tech industry has advanced so much in the last 20, 25 years, that meant that a lot of the groundwork, like the machine learning programs and packages we talked initially, a lot of the groundwork has already been done. So I think it's cheaper than ever now to start a software project. So we could iterate on a lot of ideas very early on and make mistakes that didn't cost us a lot of money or resources in general. So then the decision to stay with angel investors was really because we could do a lot of work with very few resources and spending the money very, very carefully. Sometimes, spending that on salaries, of course, for the team. Sometimes spending the money to outsource part of the project with great partners, for example, like O2H, or which you're part of, that can actually get you a very long way compared to do everything yourself from scratch. So that's to say then, if you're ever considering taking money, what is that money allowing you to do? And if you're taking a lot of money for the sake of having a lot of money in the company, or just feeling proud that you managed to raise a huge amount of money of a high valuation, that's not gonna solve any of your problems. So it's always like problem centric. In our case, for example, we really wanted to work on a let's say a prototype product. So it's what's called an MVP. So at some point we changed our approach from working on images to working on this molecular data that we talked about earlier. And that required a little bit of extra work to make sure that all the technology could work very, very well. So we had to build that technology. And also we realized we wanted to build the interface, learn more about the users. That required a little bit of time. We had to hire 1 or 2 people, and we wanted to have that the extra amount of people internally to build this team, which is still quite small. We're still like 5 people full time, but there's plenty of people to build something to start with. And we're also extremely privileged to being awarded some of governmental funds. So governmental funding can come also in terms of grants. So we managed to, so we applied for a few grants to improve our technology in the context of certain types of life sciences data, and that was great. So the moment we received that money, well, that was a great moment for us to start talking to some investors and say, look, we are going to work on this project. The government is supporting us. Normally, governmental grants work in a kind of like a refund basis. So you spend the money first, and then you get the refunds from the grant. Okay. So we talk to some investors, and to our existing investors and some new ones, and say, if you can match what we've been awarded by by the government, then it will make a lot easier for us to spend the money first, grow the team a little bit, and then get refunded from the government. So again, I don't want to get into much detail, but as you can see, there's so many different elements that have to work together, and there's no right or wrong. At each stage, you have to think what's going to be the best possible step for the next 6 months, 1 year, 2 years, whilst you still try and look ahead 10, 20 years of what the company can be then.
Right. Yeah, agreed. Thank you for sharing all these details and different aspects. I think even I didn't knew about some of the factors such as what benefits or disbenefits the other newly onboarded investor can have due to previously onboarded investors. So that was a great point. Lastly, what are your takeaways, or what are your key points that you would give to these early stage entrepreneurs or students who want to start something new?
Great question. So I think the first one is work on something that's really worth your time. So that's really important. Again, it's not I hope people think it's really not about the money in the terms of like, what is the problem you're trying to solve? It could be something that you find really annoying because you wake up every day and like, why do I have to go through this problem myself? And then actually you will be your first client where you're solving a problem for yourself. And then if you have a problem, it's very likely millions of people are going to have the same problem. Maybe they just didn't realize it yet. So choose what to work on very carefully. Don't think about how much money you'll be making, because if you're solving a problem that's worthwhile and it's worth your time, then you're going to get value back in the form of money, or in the form of like growing a company with a great team, because they're going to see how passionate you are about that problem. The other point is focus on the problem. Do not focus on the solution. Sometimes we wake up and we think like, oh, I had a great idea of something I can make that's gonna be useful for something, or maybe it's gonna solve a problem. But if you get so focused on the solution you have in mind, then it means that you might miss out on opportunities to find alternative solutions when you start talking to people that have this problem that might be easier to build, faster to make, and actually be overall more effective.
Correct.
So I will say these two would be probably my first takeaways. And then the third one, I will say, you mentioned before, so I'm gonna take that from you. Like, talk to people. I will say that be careful about your intellectual property. If you really have an idea that you think is gonna be so amazing that requires you to keep it secret, that's okay. But actually, that idea is probably some kind of solution. But you can always talk about the problem with people. So talk to people. If you think you have a solution, you want to protect it in terms of not making it public, don't talk about the solution, but talk about the problem. Can you find people that are feeling that problem? How strong do they feel that problem? And just trying to understand how they're solving it right now, because maybe their solution, which is very low tech or it's very basic, it's already better than what you're thinking of right now, and then you can move on to the next idea. What I heard in many other, like by reading books about products in particular, is that great teams that make product will realize that you can have a lot of ideas, few of those will work, and the ones that will work anyways will require a lot of iteration. So the only way to iterate is by understanding better the problems we're trying to solve and how people feel it. And so the earlier you can do that.
Taking feedback from them.
Taking feedback, making sure you really understand the people that are going to be using whatever you build as well. I find it, super important, and that's why maybe I'm leading the product development at Dimira.
That's true. With this, we'll end this podcast. And again, thank you so much for joining this podcast. And I really enjoyed this conversation. And I'm sure those audience who's listening to this podcast will have a lot of learnings.
Thank you so much, Axel. It's been brilliant to be here today. So thanks so much for the invitation again.
Thank you.